Okay, guys, two quick examples here. For each function that is one-to-one, find the inverse function, graph f and f inverse, give the domain of f and f inverse. So here's what they give us. F of x equals 4x minus 5. So the first thing you should do is verify that it has an inverse. Since this is linear and it looks like a line, I know it passes both the vertical and the horizontal line test, so I know it does have an inverse. Here's the process, okay, and I think they outline this in your book, is I'm going to change this to y equals 4x minus 5, and we know that that means the exact same thing. We're just not using the function notation. Now here's where the switching the x's and y's come in. I'm literally going to switch the x's and the y's at this point, right? So notice how I got from here to here. Okay? From here, I'm just going to resolve for y. So that means that 4y equals x plus 5, or y equals x plus 5 over 4. That is my inverse function. So in the very end, I'm just going to write it using the inverse notation. X plus 5 over 4. So there's part A right there. Now it says graph f and f inverse. Well, f is pretty easy. 4x minus 5, I know what that looks like. It's right down here, 0, negative 5, and it has a slope of 4. So it goes something kind of like this, okay? Keep in mind I can't draw perfectly, okay? Now, the inverse, x plus 5 over 4, that would have a y-intercept because we could write it like this. F inverse of x is equal to 1/4 x plus 5 over 4. That's probably more conducive to graphing. Of course, you do have your graphing calculator. And we know that that looks like this. So 5 over 4 is about right here. And 1/4. So I'm going to go up 1 and I'm going to go over 4. So that's going to be the point 4 comma, let's see, I got to add 4, 9 over 4. Okay. And notice I'll go ahead and graph that. So the x's and the y's are switched. I know I don't have the same ones, but you would see that. But the other way to tell that this really works for the graphs of two inverse functions is this. Notice what line I'm putting in right here. That's the line y equal to x. Notice that if I take this part and I flip it over, it'll land here. And if I take this part and I flip it over, it'll land here. That's true for inverse functions when you graph them. They're symmetric about the line y equal to x. Okay, so something to keep in mind. And then finally, part C here says, give the domain of f and f inverse. Well, since they're both linear functions, they're both their domains. So I'll say domain of f is all real numbers, negative infinity to infinity. And the domain of f inverse is negative infinity to infinity. So no big deal there. What I want you to think about is if the domain is all the possible x values and the range is all the possible y values for a function, what happens for its inverse function? Think about that for a second. Well, what's true is the domain and range get switched, okay? And that'll also be true for any asymptotes or anything like that, okay? So let's turn the page. Let's look at another one, okay? For the function that is one-to-one, find the following, okay? And what I just realized is that function right there is not one-to-one. So let me, if you allow me to switch that real quick. Let me find one that'll work for us. Yeah, let's do this one. Let's do f of x equals 1 over x plus 2. Okay? We know what that looks like, right? In fact, I'll even graph that one first. Okay? So 1 over x plus 2, if you remember from our chapter 3, that'll look like this. They'll have a vertical asymptote at x equals to negative 2. That's easy to see because we can't have a 0 in the bottom. And remember, it resembles f of x equals 1 over x. So it has that horizontal asymptote of y equals 0, and it looks like this. So that is my original function, okay? Now, it'll probably get a little messy when I put the other one on here, but just bear with me, okay? So first of all, let's find f inverse. So part A, I have f of x equals 1 over x plus 2. So the very first thing I'm going to do is I'm going to switch it to y equals 1 over x plus 2. Okay. Switch the x and y's. This is where we do the inverting part. And then I'm going to resolve for y. So when you look at this, you got to ask yourself, okay, how do I solve that for y? Well, a good starting point would be get rid of that fraction. So if I multiply both sides by y plus 2, okay, hopefully that's kind of reviewish for you. Okay, so what we have now is we have xy plus 2x, I just distributed, is equal to 1. Okay. Alternatively, I could have divided by x first and then subtracted 2. I just decided to do it like this. So xy equals 1 minus 2x. So finally, y is equal to 1 minus 2x over x. Well, really, that's my f inverse of x, is 1 minus 2x over x. So, to tell you the truth, I do know how to graph this right now, okay? But it may be a good idea to go ahead, bust it out on the graphing calculator, then we'll see kind of what happens. So, 1 minus 2x over x, I'm going to graph that out right now. And it looks like this, okay? So I want you to look at these things. Here's the thing I want you to notice. On our graph of our original function, okay, I have a horizontal asymptote at y equal to 0. Notice on my inverse function I just graphed, I have a vertical asymptote at x equal to 0. So it's kind of like my horizontal and vertical asymptotes switched, okay? Here's the other thing I want you to notice. My vertical asymptote was x equal to -2 on my original function. Okay? And it seems as if my horizontal asymptote, especially if I zoom in, is y equal to -2. I guess it's a little hard to see. I can maybe trace some values. So see, I have y values, y values, y values. But it's getting closer and closer to 2, but it just kind of keeps going. There's a horizontal asymptote at y equal to -2. So my horizontal and vertical asymptotes literally flip-flop. Okay? So let's go back to our original graph. I guess I should. Let me just open it back up real fast. Oh yeah, zoom out. There we go. Okay, so this thing's going to look very similar, except for, so I'm going to try to graph this on the same one. I'm going to have a horizontal asymptote. Now remember, this is for the red. That doesn't affect this. At y equal to -2, and I have a vertical asymptote at x equal to 0. Okay, and what it looks like is happening is I'm getting something like this. Now it's a little hard to see what happens when you flip this over the line y equals to x, but you can see it with some of these values, especially right up here, right? If I flip this, I'll hit here. If I flip this, I'll hit here. Okay, so you can sort of see it, but granted, it is harder, especially with these rational functions. Last question is domain and range. So what is the domain of f? Okay. So the domain of f we know is everything but -2. So that's going to be -infinity to -2 union -2 to infinity. Okay. If I know the domain of f, that means I know the range of f inverse. I just realized I forgot to do the range on the last one. It's all real numbers. So that should match the range of my inverse, right? Because the domains and ranges get switched. And let's see, if you look at our graph, there's our horizontal asymptote. That does match up as expected, okay? Well, what's the range of f, or sorry, what's the domain of f inverse? Okay. Well, the domain of F inverse is everything where x is not equal to 0. You can see that right from here. Okay. So negative infinity to 0, union 0 to infinity. And of course, the domain of the domain of F inverse is equal to the range of F. Negative infinity to 0, union 0 to infinity. Okay, so there we go. And that'll always be true for inverse functions. Okay. This is pretty good because sometimes the ranges are a little harder to find. So if you know the domain of F and the domain of F inverse, then you actually have the ranges. All right, that does it for 4.1.